This is our Chem extra credit project, and my name is Meghana.
I'm Shreya.
I'm Raneen.
And I'm Saylin.
Our question is, how do bond length and energy behave as you increase bond order?
My name is Saylin. Bond length is the distance between two nuclei of atoms formed by a covalent bond. The length of a bond is dependent on and determined by the number of electrons being bonded in a bond order. As you can see from each molecule in the slide, as the number of bonds increases, the distance will shorten.
Hi, my name is Raneen. The bond order is the number of covalent bonds shared between two atoms. In a single bond, there is one sigma and zero pi bonds, but as the bond order increases, more pi bonds are added. For instance, in a double bond, there is one sigma and one pi bond, while in triple bond, there is one sigma and two pi bonds.
This is Meghana. Bond energy is the attraction between two atoms that are stabilized by a covalent bond.
This is Shreya. This is a graph which represents the relationships of bond order, bond energy, and bond length. As you can see, the x-axis is represented as the distance between the two nuclei of the atoms, while the y-axis is represented by the potential energy. So, at step 1, the two atoms are far apart from each other and have zero interaction. The bond length is high because they are far apart from each other. This means that the bond energy is also low because it does not require much energy to break the bond. But in step 2, they are attracted to each other and the bond length decreases, resulting in an increase in bond energy as well as bond order.
At step 3, the atoms get as close as possible and reach an equilibrium, meaning that it is at its maximum bond order and bond energy. Here, the bond length is very small. However, as the interaction increases, they eventually repel each other.
Hello, this is Saylin again. Now we transition to the overall idea. When the number of shared electrons rises in a bond, the force of attraction between the two nuclei of atoms grows stronger. This pulls the attraction in the bond closer and stronger, which shortens the distance between the two atoms. As the attraction in the bond increases in strength, more energy is required to break the bond because the atoms will be harder to pull apart, meaning repulsion is less likely.
As bond order increases, the attraction between two atoms becomes stronger and stable, making it harder to pull the two atoms apart, thus requiring more bond energy. This attraction between the covalent bonds brings atoms closer together, causing a